In this video, we're going to be talking about similar right triangles. So on the screen, you have two similar right triangles. We know that they're similar because all of the angle measures are congruent across the triangles. These are what we refer to as 45, 45, 90 triangles, meaning they have two 45-degree angles and one 90-degree angle. If we have two angles that are congruent, that means that this must be an isosceles triangle. And if it's an isosceles triangle, that means that the sides across from the congruent angles must be congruent. And if you look at the two triangles, you'll see that that is true. Across from our 45, 45 angles, we have congruent sides. On the left triangle, they're 5 and 5. On the right triangle, they're 3 and 3. So this is nothing new, but we're going to be looking at the ratios within the triangles. Now by that I mean we're going to look at the leg over the leg. We're going to look at the leg over the hypotenuse or the hypotenuse over the leg. And I want to show you and make you understand that the ratios are the same within these right triangles. So if you look at leg over leg, let's look at the ratio of that in each of these triangles. So in our left triangle, we have our two legs, which are 5 and 5. So we're going to look at the ratio of 5 over 5. And in our right triangle, we have 3 over 3 for our two leg lengths. Both of these fractions simplify down to be 1 over 1, which is 1. So the ratio of the leg over the leg is always 1 if you have a 45, 45, 90 triangle. This should make sense because in every one of these triangles, the two legs are going to be congruent, so the ratio is 1. Now let's look at the hypotenuse over the leg. So this is a little bit different. Your hypotenuse in your left triangle is the square root of 5, is 5 square root 2 over 5, and in the right triangle is 3 square root 2 over 3. Now, we can't divide a square root number by a whole number, but we can divide whole numbers by whole numbers. So we've got some things that can cancel out here. If we've got a 5 on top and a 5 on bottom, and neither one of them's under the square root, 5 divided by 5 is 1. So these two cancel out. And check out your other one, 3 square root 2 over 3. These cancel out as well. So the ratio of the hypotenuse over the leg is the square root of 2 over 1, which means that the ratio is square root 2. So what I want you to take away from this is that no matter how big or small a 45, 45, 90 triangle is, the legs are always congruent, and the hypotenuse is always the leg length times the square root of 2, because these ratios stay the same in every 45, 45, 90 triangle. Next we have a 30, 60, 90 triangle. In a 30, 60, 90 triangle, the ratios within the triangles is similar as well. So again, we know there's a scale factor because we know that these two triangles are similar, so I'm not going to go through all that. But let's look at the ratio of the long leg to the short leg. So your long leg in your left triangle is 5 square root 3, and your short leg is 5. In the right triangle, or the triangle on the right, the long leg length is 2 square root 3, and the short leg length is 2. Now we have canceling out again. The 5's cancel out, the 2's cancel out. So your ratio is simply square root of 3 over 1, which is square root of 3. Now let's look at the hypotenuse over the short leg. Your hypotenuse over the short leg in the left triangle is 10 over 5. In the right triangle, it's 4 over 2. So that means that both of these are going to simplify to be 2 over 1, because 10 divided by 5 is 2, 4 divided by 2 is 2, so your ratio is 2 to 1. So what you need to know about this is that your hypotenuse is always your short leg times 2. Your long leg is your short leg times the square root of 3. So all similar triangles have common ratios within sides, and we're going to be using these common ratios to solve for missing sides. Your calculator has all of those ratios saved. Okay, that's your sine, cosine, and tangent button. You know them as the sin, cos, and tan. So we're going to be introducing those buttons to you over the next couple of days. And those buttons have the ratio saved for every single angle measure that exists that could possibly make up a right triangle. For right now, for this video, your questions have stuck to just your 45, 45, 90 triangles and your 30, 60, 90 triangles. But we'll get into finding any side length measure of any angle measure of any right triangle that exists.